Happy Wednesday, you all. So on that quiz you guys took, so if you hadn't been noticing, in each video, during the video, I would say, this question might be on your quiz. And I even had a list on a yellow piece of paper that every time I talked about it, I would write the question down that would be on the quiz. I only put those questions on the quiz. So make sure that if you didn't do too well, that from now on, during these lessons, when I make something very clear that I'm going to quiz you on, make a note of it, because I will. Um, these chemistry quizzes, my goal is to be easier rather than harder, because this is tough to do from home. So I'm going to spoon feed you guys a little bit with the questions. So please don't get lost there. Please make sure that you're paying attention. As you can see, the first meme of the day has been submitted. I'm sure you guys can guess who submitted it. Yeah. I'm not even gonna say anything. But the pOH scale. So what the heck's the pOH scale? So the pH scale was a way to denote the hydronium content in something without having to use scientific notation. So guess what pOH is? pOH is also a way to describe ion concentration without using scientific notation. So number one's the exact same for pOH and pH. They're both used for the same thing, except the pOH scale. The pOH of a solution is the negative logarithm of the molar hydroxide. This may look the same as yesterday, but it is not. So the pOH is the negative log, we're still taking a negative log, of the molar hydroxide. So instead of taking the log of the hydronium number, we're going to be taking the log of the hydroxide number. Now, where this gets funny and tricky is that usually you're looking for the hydroxide content and you have the hydronium. Because usually you're adding an acid to something, so you know the hydronium, but you don't know the hydroxide. So usually you won't be taking the negative log of a molar hydroxide. Usually you're going to be having to do something else. So here's our equation to start with. pOH equals negative log of the hydroxide. Look at that handwriting, yo. It's nowhere near as good as Haley's, but it's still good. Okay, so it's literally the same equation as yesterday, um, except you're using the hydroxide instead of the hydronium. So let's say I did ask you for the pOH of pure water. Okay? It's probably not going to happen, but let's just say I did. Well, we know that my equation is pOH equals the negative log of the hydroxide. We know that the hydroxide and the hydronium content are both 1.0 times 10 to the negative 7. That was a quiz question. And that the KOH, or I'm sorry, the KEQ is 1.0 times 10 to the 14th. That was negative 14th. That was directly in our notes. So I just have to plug my number in right here. pOH equals negative logarithm of 1.0 times 10 to the negative 7th. And if you think about this, for water, this is the exact same equation I had for pH. So guess what happens? The logarithm of 1.0 times 10 to the negative 7 gives me negative 7.0. So the pOH I end up getting, negative 7, is 7.0. The pOH is the same as the pH. How weird is that? That's because it's a neutral solution. It's not more alkaline, and it's not more acidic. However, now that we have this under our belts, there are two more mini equations. I'd call this a major equation. There are two mini equations that we're going to end up using a heck of a lot more than that one. And these two are more important, in my opinion. So what are they? The first equation you're going to be using more of is H3O plus equals 10 to the negative pH. Okay? H3O plus equals 10 to the negative pH. That's one equation we're going to be using more often. And the other one we're going to be using more often is pH plus pOH equals 14.0. But Mr. Brown, you might ask, this is the pOH section. Why are we doing equations with pH? Well, that is because pH and pOH are what I'd call inextricably linked. You can't do one without the other. I know we did yesterday, but that doesn't count because we were learning. This pH and pOH, usually what you do is I ask you, what's the hydroxide content? I'm going to give you the pH. What you have to do is plug in the pH here to find your H3O. Use your H3O. Um, I'm sorry, I had a brain fart. No, if I give you the pH and say, let's say the pH is 3, you'd plug it in here. 3 plus pOH equals 14. Subtract 3 from both sides, your pOH is 11. Um, if you really want to, I'm going to give you 2 extra mini ways to write this, and this might be helpful for your notes. Um, if you're solving for pH, your equation is going to be 14.0 minus pOH. And if you're solving for pOH, your equation is going to be pOH equals 14 minus 14.0 minus pH. So basically, whichever one you're solving for, you're going to subtract the other one from 14. Let's put these in little braces. Okay. So don't get overwhelmed. H3O plus equals 10 to the negative pH. This looks strikingly similar to this equation from yesterday, does it not? That's because it is. So these are 2 ways of writing the same thing. Okay? What we did here, let me get out my little scratch sheet of paper. Here we go. How we got this, I'm not going to drag this out too long. How we got this is if we had if we had pH equals negative logarithm of H3O plus, and keep in mind that we have a little base 10 down here. This is why I'm doing logs in the math class as well, by the way. You can rewrite this as 10 to the pH equals H3O plus. And that negative gets switched to the other side. So this is a mathematical way with logs to actually move the bases and exponents, but that doesn't matter a whole lot. Let's look at how this is applied. I'm actually going to use a completely separate piece of paper so I can keep this on the page at all times so we can reference it. There we go. Okay, so I'm going to be working in the book on page 416, and I'm going to show you guys how this is applied. So, on page 416, I have example problem 16-4. And this one's super important, by the way. Let's see, on our calendar, I have a take-home quiz this Friday on pH, pOH, and acid-base strength. Um, this problem will definitely show up on that. So put a big star in your notes or something. So, 16-4. a 0.10 molar hydrochloric acid solution has a has a hydronium hydronium concentration of 1.0 times 10 to the negative 1 mole over liter. Calculate the pH, the pOH, and the hydroxide content of the solution. Wow, we got to solve for 3 different things. Well, rest assured, it's easy to get overwhelmed, but none of the 3 things are hard to solve for, because one of them we've already done. So first, let's calculate pH. Let's look at our notes. What was the pH equation? pH equals negative log of hydronium content. So there's my hydronium content, see? H3O plus concentration of 1.0 times 10 to the negative 1 moles per liter. So let's plug this into our equation. pH equals negative log of H3O plus. So I'm going to plug that in. pH equals negative logarithm of 1.0 times 10 to the negative 1. If I type this into my calculator, pH equals logarithm of this number gives me negative 1, and then these negatives cancel out, and my pH is 1.00. Cool. There's step 1. Here's step 2. I need to find the pOH. What equation did we find today where if I have the pH, I can find the pOH? This one doesn't help. Hey, I have the pH, and I'm looking for the pOH. So I'm going to use this one because I'm looking for the pOH. So the pOH equals 14 minus the pH. Okay? So what's my pH now? 1. What's 14 minus 1? Oh wow, guys, this is getting hard. My pOH content is 13.0. Fantastic. Now I have step 3. I need to find the hydroxide content. All right. Step 3. I need to find the hydroxide content. So what do I do? Well, if we're looking for the hydroxide content, we learned an equation today that should help us with that, and it was right. Um, where was it? Was it really literally right there? Yeah, yeah, yeah. It was right there. Okay. So it probably would have helped you guys if I had written this, but I forgot to write both of them. There's one more of these. This works for both pH and pOH. Like I said, they're super linked together. So I just found my pOH, so I can use the pOH to solve for my OH. So that's what I'm going to do. My OH minus content equals 10 to the negative pOH. What did I just find pOH to be? 13. So if I plug my numbers in, OH minus equals 10 to the negative 13. Well, what do I get? What's my OH content? Well, the way to rewrite 10 to the negative 13 in scientific notation would be 1.0 times 10 to the negative 13. There is my hydroxide. So, this is the big piece of hydroxide, okay? This is where yesterday and today are leading. If you're given one piece of the puzzle, can you find the other three pieces? We got hydronium, so we had to find hydroxide, pOH, and pH. If you're given pH, can you find pOH, hydroxide, and hydronium? If you're given pOH, can you find pH, hydroxide, and hydronium? If you're given OH, can you find pOH, pH, and hydronium? So let us move on. I believe there's one more problem in this chapter. Yes, there is. 16-5 right on the next page. What does it say? A sulfuric acid solution has a hydronium content. I keep saying content. Has a hydronium ion concentration of 3.2 times 10 to the negative 2 moles per liter. And what is moles per liter? That's literally just the capital M. I don't know why they keep writing like this in the book. It's dumb. Calculate the pH, pOH, and the OH minus. Alrighty. Okay. So, what am I given? I'm given the hydronium content. What can I find with the hydronium content? Well, pH. We did that yesterday. I can find the pOH, I'm sorry, the pH with negative log of the hydronium content. So step one, if I plug that in, they give me H3O, which is 3.2 times 10 to the 2. What do I get when I type in logarithm of that into my calculator? I get negative 1.49. Negative 1.49 gives me positive 1.49. That's my pH. That's step one. Now I gotta find my pOH. What's my little equation to find pOH? That one. pOH equals 14 minus pH. Cool. So what's 14 minus 1.49? My pOH equals 12.51. Cool. Step 3. What's my hydroxide content? What's my equation to find hydroxide? Dat one. Hydroxide equals 10 to the negative pOH power. Hydroxide equals 10 to the negative pOH, 12.51. And what happens when I type this into my calculator? Please be careful with the negative exponents. Make sure that your calculator, you use parentheses if you can. When I plug that into my calculator, I get 3.1 times 10 to the negative 13. And that's my answer. Oh, I didn't even check these off as I found them. Darn it. Two problems, almost exactly the same. And I can promise you there's going to be probably two problems exactly the same on your next quiz, which is Friday. Yes, it's Friday. Anyway, that's pOH. Um, Tomorrow we'll talk about acid-base strength, and that'll be that. So let me give you guys a homework assignment real quick. Um, this is going to be a little unconventional, but what I'd like you guys to do is to do the 16-4 problem, but your H3O concentration is 3.5 times 10 to the negative 3 moles per liter instead. So do this problem in the book, except change this number to this. Okay? And then I want you to do this problem, but your H3O plus concentration is 6.1 times 10 to the negative fourth moles per liter. So basically, instead of handwriting these problems out and taking 5 minutes of the video to do it, I'd like to just, if you guys could just do those two problems, but change the main important number to here on 16-4 and change 16-5's number to be this one, that would be perfect. Well, I'm hoping you guys aren't too confused on pH and pOH. I'm hoping it kind of makes sense a little bit. If it's not making sense, please let me know and I can help you. With that being said, I hope you guys have a splendid Wednesday. Bye. Where's my button to turn it off?